Hello guys, welcome to my YouTube channel. My name is Shambhu and in this video I am going to take forward my EVPN discussion. So last video I have discussed about single home EVPN session. I had two hosts, one was connected on CE1 iOS and another was connected on CE2 iOS. In this video I am going to focus on this part of the network where I have a multi-home device set up here, and we'll see that how this multi-home device is going to communicate with this single home device, or how this multi-home device as a whole communicates with other side of the network. In ISP network, I have OSPF running between all these devices to exchange the loopback interfaces. And on top of that, I have this PXR1 router. This is the route reflector, which is configured to reflect route between PE1XE, PE2XE, and PE3XE. So let's get started. What do I mean by multi-home first of all? So if you remember from legacy L2 VPN days, you might not have seen this kind of implementation because this kind of implementation is not supported over those protocols for L2 VPN extension, whatever we have today. Now with EVPN, we get this extra feature where one switch or any of the device, maybe in data center, you can have Nexus devices or any device which supports L2 port channel basically. That device can have multiple connections bundled into a port channel going towards the ISP, and we can keep both of these connections active at the same time. So you might have guessed that this connection can be used for load sharing, and also this can be used for failure prevention, where one side of the network is down, you would still have another side of the network, which will prevent traffic drops in the network. So we'll see how this is going to work. First of all, let's get started with the network configuration. I'll move to console sessions of these devices and show you the configuration. Okay, so this is my PE1XE router. You can see right side of the screen. I have PE1XE console, PE2XE console, and CE1 iOS console opened for now. So if I show you the interfaces here, I have show IP interface brief. I have gig1 interface, which is going towards the core. And I have a loopback 1111. And also I have a gig2 interface, which is basically going towards CE1 iOS router. Before I get into BGP and EVPN configurations, I'll talk a little about OSPF and LDP sessions because that will build the foundation for this network. I know I have discussed this in my previous video, but I don't know you have seen that or not. So let me just quickly show you that what OSPF and LDP connections I have. Over the interface gig1, I have OSPF and LDP enabled, and loopback 1 I am advertising into OSPF. If you see show IP OSPF neighbor, I have a neighborship running between 1111, which is PE1XE router, and PXR1 router, which is a route reflector. And here is the configuration for the OSPF. Show run section router OSPF. You can see the router ID is 1111, and I am advertising all the interfaces, whatever I have. I just have one interface, so this I have just casually put this command here. This should be fine. If you want to see what LDP neighbors I have, show MPLS LDP neighbors. So I have one LDP peer, just like the OSPF peer. I have 5555 as my LDP peer. This is all about the basic, transport connectivity. Over this transport, I am going to build BGP and EVPN sessions. So now let me show you the other part of the network, which is going towards the customer. That means gig2 interface, which is connected to CE1 iOS router. If I do show run interface gig2, you can see that I have put this particular interface in a channel group. I have kept the channel group mode as on because other modes are not supporting on iOS XE devices. If you want to see the port channel configuration, here it is. It also has some of the component about EVPN Ethernet segment. You can ignore this part for now. I'll come back to that part. You can focus here. Here I have service instance 10 Ethernet, and encapsulation is untagged, which means that I am providing a VLAN to customer, which is accepting basically untagged traffic for now. And over the PE2XE router also, exact mirror image configuration is done. So I'm not going to go through PE2XE router configuration because that is going to take time. So I'm not going to show that because that is exactly same. You can configure the exact same thing what I have here, and we should be good. Let me quickly show you the configuration on CE1 device here. This is our traditional Ethernet device, and here nothing else is needed. Just these two interfaces, gig 0 by 0 and 0 by 1, should be configured for the VLAN, which is allowed over these interfaces. We can check that with show run interface gig 0 by 0. You can see that I have a VLAN 20 configured, and I have kept switch port mode as access, so I don't want any tag traffic here. Just like you have seen on PE1XE, I have kept the encapsulation as untagged. And over the gig interface 0 by 1 also the exact same configuration. I have channel group configuration also. So these two interfaces are configured in bundle mode. Let's see what are the other interfaces that I have configured here. So IP interface brief. So I have these two interfaces up. There is no other interface which is active. And these two loopbacks you can just ignore for now. And I have port channel 10 configured. Let's see if I have any configuration there or not. Channel 10. That is also configured for VLAN 20. There is nothing much configured over port channel 10 as well. I have one IP assigned on VLAN 20. Apart from this, on this particular device, I don't have anything, just simple basic Ethernet configuration and VLAN configurations to have a connections active between CE1 iOS and these two devices. That is all. So with this, let's quickly go to the configuration of EVPN on PE1XE router and PE2XE router. And before I get into the actual configuration, I'll show you the configuration guide which I am going to follow. This is MPLS L2 VPN configuration guide for iOS XE devices. Let's go to the configuration quickly. Here you can see that I have a similar kind of topology. Here they have one side they have a port channel which is connecting three PE devices. So this tells you that you can have two or more than two devices configured as PE. So here we have PE1 router, PE2 router, and PE3 router, which is going towards a switch, which has a port channel going towards all these three devices. The other side of the network, we have one switch which is connected with a port channel 1 to PE3, PE4 and PE5 routers. This part of the network is similar as my configuration that I have on GNS3. I also have a switch which is having a dual home connected towards the ISP network. Now let's quickly see the configuration parts of the configuration that we have. We start from here. We configure L2 VPN and replication type as ingress and a router ID as loopback zeros. Ingress replication is nothing but it means that whenever these PE devices would receive bump traffic, which means broadcast, unknown unicast, and multicast traffic, that would be replicated at here itself. That means the PE4 router, if it is going to receive the bump traffic, then it will replicate the number of copies for the interested PEs, and it will send one copy to each of those devices. So that is called ingress replication. If you don't have multicast backbone configured, then you need to have the ingress replication to forward that kind of traffic. So those are two methods. One method is to use multicast in your backbone, and if you're not using that, or if your transport is not allowing multicast, then you can have ingress replication, which will make the copies at the head-end router itself and send all the copies to all interested nodes, whichever are there. You can see that the configuration is looking very, very simple here. I have this configuration, that means VLAN based EVPN instance that I have. If you want to identify the difference between VLAN based, VLAN bundle, and VLAN aware, you can just go to this EVPN single home configuration site, and you can find the explanation here. You can see that they have explained VLAN based service instance or VLAN bundle service interfaces and VLAN aware service interfaces. So these are three type of implementation that we have. I'll go to the EVPN multi-homing page again, and let's go to the configuration part. So once you have this part configured, we need to go and configure the port channel. I have showed the configuration on port channel to you. Here, you'll have to specify the Ethernet segment. So this is a very important part because this particular Ethernet segment is common between PE1 and PE2 router. We need to make sure that both of the segment which are configured on PE1 and PE2 router should have exactly same Ethernet segment ID, and that is derived with the system MAC. We need to keep the system MAC as same on both of these routers. You need to put this particular part of the configuration under the port channel, EVPN Ethernet segment. You can name the Ethernet segment anything, and then the identifier, and then the system MAC needs to be specified, which should be same between PE1 and PE2 router. And after specifying the system MAC, etc., you just need to tell if you are going to configure redundancy mode as all active or single active. The difference between all active and single active is, for example, in this setup, if you keep it all active, then both of these links would be forwarding traffic and receiving over it. But if you keep one active, then another link would remain standby. It would not forward traffic. As soon as one link goes down, then other link would become active. That is the only difference between all active and single active. In my case, I have all active configured here. Now we can specify all kind of service instances what we are allowing over that port channel. In my case, I just have one VLAN, which is VLAN 20, and that is also untagged in nature. Now, once we have these two things configured, that means configure L2 VPN globally and configure the access interface, then we'll have to latch these two parts of the configuration. That means we get into the bridge domain and we specify the member, which is a port channel 1 service instance 10 in this case. And also I specify the EVPN instance, which I have configured here. These two configuration are kind of stitched together in the bridge domain configuration. And after that, we just need to enable the L2 VPN, EVPN address families between the PE routers. So let me quickly jump to my routers and show you the how I did these configuration on my routers. Okay, so this is my PE router. If I'll just put the complete show configuration here. Here you can see that I have L2 VPN, EVPN configuration, ingress, replication type is ingress, and you can ignore this part of the configuration. It is not needed basically here. Router ID I configured as loopback 1. I am configuring the EVPN instance of a VLAN based type. The second part of the configuration is the port channel configuration. So here you can see that I have configured EVPN segment 1 and the system MAC is ABCD, 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 which I have kept the redundancy as all active here. Now the port channel, that means access side interface, and the EVPN globally is enabled here. Now I'll go and latch these two configurations. Under the bridge domain, I have port channel service instance 10 and EVPN instance 10. You can quickly verify it. EVPN instance is 10, and under the port channel, you can see that the service instance 10 is configured under the port channel. So these two things I have basically latched here or stitched together. Now, apart from this, I'll get into the BGP configuration. So I have just one iBGP neighbor, which is my route reflector, because I am receiving everything from my route reflector. Now, under the route reflector, I have configured L2 VPN, EVPN services, and I have activated it and enabled send extended community, because there are a lot of details or BGP updates about EVPN. It will be forwarded in form of extended community, so that is important to be enabled. That is all. That is the complete configuration that we need for the multi-home setup. Now quickly let me show you the PE2 configuration also. You can just verify that it is exactly the mirror image configuration what we have done on PE1 XE router. I'll just do show run so that we can see the complete configuration. Here you can see that L2 VPN ingress type and router ID is mentioned. The EVPN instance I kept same on both of these devices, which is of type VLAN based. And then if you see the port channel configuration, you can see the system MAC is same, ABCD, ABCD, ABCD. and redundancy mode is also all active. So I'll be forwarding data over this interface and also over this interface. Both of these interfaces are active. EFP, what I have on this interface is EFP10 or service instance 10, and the encapsulation type is untagged. Now I am latching these two things together in bridge domain 10, and you can see the BGP configuration. It is exactly same mirror image of the configuration what I have on PE1XE router. The other side configuration, that means PE3XE router configuration, if you want to see, I really don't need to do any multi-homing configurations there because the Ethernet segment ID would be all zeros in this case. There is no multi-homing, so that is not needed. Still, I'll show you the complete configuration, what I have just for the reference. We can see that L2 VPN configuration is exactly same here also. So in single home and multi-home, both of the places, you need this global configuration, which needs to be there. In bridge domain configuration, instead of having port channel, I am having gig interface, gig 2 interface, which is going towards my CE. And the service instance is 10 here also in this case. EVPN instance is 10, as you have seen. Now, if we go down a little and see the gig 2 interface, it is quite similar. The only thing which is missing from this configuration is the Ethernet segment configuration. It is not needed here because we are not doing any multi-homing configuration. So here we have service instance 10 Ethernet and encapsulation is configured as untagged. I want to have the communication between CE1 iOS and CE2 iOS over this part of the network. And in terms of BGP configuration, we can see that we just need L2 EVPN address family and exactly same configuration what we have on P2 and PE1 router, that is same configured here also. So good, this is all the configuration that I have. Now let's quickly move to the verification part of it. I will start the verification part of the video with the ping. So I'll go to CE1 router first of all. I'm sorry, this is a switch. You already know that I have a VLAN configured. So run interface VLAN 20, which has IP address as 20.20.21. And other side of the network on CE2 iOS router, I have show IP interface brief. I have one interface which is configured with the IP address of 20.20.22. So I'm going to ping from here to here, and the data should be going either on this interface or this interface, and from here or here it might be going on this interface or this interface, and then it will go like this, and then it will come to a CE2 router where the interface is configured for 2020-22. So let's go to C1 and ping 2020-21. You can see it is self ping is working. Now let me see if this is working. All right, so good. We are able to ping 2020-22. Let me see if it is exactly going over the L2 transport. So for that, I'm going to trace 2020-22. It should not take more than one hop, which is basically kind of directly connected device. So you can see that no hops here, just the router which is owning this particular IP. So that means we have the L2 domain extended from here all the way through ISP till here on CE2 router. So this is working. Now let me quickly jump to PE1XE router and show you some of the verification command, which is quite handy on these devices. First of all, you need to see if the L2 VPN, BGP, EVPN address family is up or not. So for that, you need to do show BGP, L2 VPN, EVPN summary. We have the session active between PE1XE router and the route reflector, and it is also receiving some of the prefixes. If you want to check those prefixes, I'll go to the same command, just remove the summary part of it, and you'll see all the routes that it is receiving. So basically in this case, there are different kind of routes that we are going to send, and those routes are route type 1, route type 2, route type 3 and 4 and so on. So I'm going to make a separate video on these route types because these route types are very important. These are kind of heart and soul of EVPN operations. So it is very important to understand all these route types, but Since I'm just discussing configuration here, I'm not going to discuss all these route types here. Let's keep it for the next video. Let's see some more verification commands. If I do show L2 VPN, EVPN summary, let's see what I'm seeing here. You have some very basic details here, like how many bridge domains are there, what kind of EVPN is configured, and what is the router ID, and type of replication, what is it, and if the core is active or not, and how many MAC is learned, etc. There is another interesting command which is show L2 VPN EVPN EVI, and then if we put question mark, if we put detail here, this command is very important because this would tell you if this router is running as a multi-hop router or not. And that detail we get out of this output. This output is saying that DF state is forwarding here. And if we check the same command output on my peer, that means on PE2XE router, you can see that it says that DF state is PE to CE, bum traffic blocked. So what happens while the multi-home setup is coming up? They elect one router as a designated forwarder, and that designated forwarder has the role to forward the bum traffic towards the CE router. And this mechanism is actually preventing the loop in this kind of network. In situations where, for example, this CE1 iOS router is generating a broadcast packet, it goes here, it will make two copies of broadcast packet because I have PE2XE and PE3XE. So that broadcast would go to PE3XE and it will also be received by PE2XE router. Now, if PE2XE router is not blocking PE to CE broadcast, then you can see that the broadcast traffic would travel all across the network and would be received by CE1 router itself. And that would cause a loop. So in order to prevent that kind of scenario, we'll have to have one device where the broadcast or unknown unicast or the multicast traffic is blocked. So that is the reason we have the DF state on PE2 router as PE to CE bum traffic blocked state. Apart from this, there are other details like state is active and all those state that you can find here. But I think this level of verification is good. Now let me quickly jump to some of the Wireshark capture and show you that how exactly this multi-homing is working. So for packet captures, I'm going to enable packet capture over this interface and this interface. I just want to see that which interface is forwarding traffic, and also on this interface and this interface. So let's quickly enable that. It is very important that we enable packet capture on both of these interfaces because this is a switch and we have a port channel which is going towards the ISP. So ping traffic can be hashed to either of these ports, right? Any traffic can be hashed to either of these ports. Wireshark is running in the separate window. So let me just start ping here and then I'll move to Wireshark window. So I'll do 202022. All right, we must be having captures. Now I'll just stop these captures. Okay, now let me go to the Wireshark window. Okay, so here I have the capture which was running between CE1 iOS router. You can see the name here, CE1 iOS gig interface 0 by 1. And the capture was taken between CE1 iOS router and PE2XE router. And the right side we have CE1 iOS router and PE1XE router. You can see that the ICMP request and responses are taking two different paths. So I have this ICMP request, which is going to my PE2 router, but I see that response is coming over the PE1XE router. This means that our multi-homing setup is working quite perfectly, and it is also load balancing traffic over two active links, or we have configured redundancy all active, right? So that redundancy all active part is working quite perfectly. Now, if this is happening, then in the core also, the ICMP request must be getting forwarded with PE2XE router and the response must be coming to PE1XE router. So let me quickly jump to those two captures, which I have taken over these two interfaces. So for now, we have seen the capture here and here. it says that the request is going here and the response is coming back out of this interface. Now I'm going to show the captures here and here. These are the captures. So I have two captures left and right of my screen. These are the captures taken on PE1XC and P router, or the route reflector router, and also PE2XE and the route reflector router. It is the capture from the core interface. So which means we are sending the encapsulated packet. That means we are sending the packets which are having labels, and it is basically L2 VPN, EVPN encapsulated packet that we are sending. So those packets would be seen as LLC packet. Now don't get confused with this. This is nothing but ICMP echo request and echo response packets. You just need to decode these packets. So for that, you can right click on this packet. You can decode as Ethernet pseudowire no control word. You can select that here and put OK. And after that, you would be seeing that this particular packet is a echo response packet, right? Similarly, I'm going to do the same thing in the other packet also, and I'm going to select Ethernet pseudowire no control word. And here we are seeing that this is a echo request packet. That means our echo request packet is going over PE2 router to the route reflector, and then reflector is sending it to PE3 router. Similarly, the response is coming from route reflector to our PE1 router, which is this one, PE1 router, and the PE1 router is sending the response to the CE device over the Ethernet segment that we have configured. So this is working quite well, and we are also able to see the load balancing, or you may say load sharing here. The load balancing type is per flow. With this, I'll stop this video because this is already a long video, but I hope that you might have got a gist of multi-homing, that what exactly it is, how it is configurable, and how the packet is being forwarded in a multi-homing setup. In next video, I am going to focus on route type, and also I'll see how bump traffic is working, because in order for the ping to work, we need to have ARP resolved, right? And we have not seen that how exactly ARP is getting resolved in this network. So in my next video, I'll focus on ARP and different route types that we have, because that discussion is very important in order to understand nitty-gritties of EVPN. So stay tuned. Please keep watching the videos and subscribe to the channel, and happy learning.